Dear students, let me continue in our presentations. For today, I prepared a lecture about hydrogen technologies. If we take, for example, energy efficiency of coal, it is 34 megajoule per kilogram. If we take diesel, it is 43 megajoule per kilogram. And if we take hydrogen, it is 120 megajoule per kilogram. So in every kilogram of hydrogen, there is the energy 16 kilowatt hours. What are typical cars consumption and bus consumption? If we take passenger cars, they have a tank 5 kilogram and consumption is 1 kilogram per 100 kilometers. So per the one tank you can drive 500 kilometers. If we take a 12-meter bus, the tank is 35 kilograms and hydrogen consumption is 8 kilograms per 100 kilometers, so the driving range is 350 kilometers. What is the main principle of fuel cells, hydrogen fuel cells? We have hydrogen cells, we have a membrane, and the hydrogen is divided into positively charged hydrogen and negatively charged electrons. And this membrane works that hydrogen can go through this membrane, but the electron cannot go, so they must take alternative paths and they produce the electricity. And in the right side of fuel cells, there is created heat and water. So it is the example of practical polymer electrolyte membrane fuel cell that is very typical hydrogen fuel cells that is practically used. I have for you some specification of mobile hydrogen refueling stations that are used in many purposes. For example, in application in railway system in Germany. So you can see that standalone tank system is for 350 bar refueling. Discharging capacity is 180 kilogram per day. There is the availability 24 hours, whole weeks, and with smart controls and so on and so on. So it is the picture and example of this mobile hydrogen refueling stations. The input of this hydrogen refueling station can come from photovoltaic panels, for example, or solar system, and then we speak about clean green hydrogen. Now hydrogen can be used in many transportation means. I have for you examples of buses, boats. There is also first Toyota Mirai hydrogen passenger cars, and you can see that there is fuel cells and also the battery, and this is the high pressure hydrogen tanks on this slide, and it is the commercial car, hydrogen passenger car that is in the market now. In Germany is very popular hydrogen trains. Then you can see the whole cycle of production of electricity from solar and wind power, so there is a great stabilization. It is input to hydrogen generation and storage fuel stations, and from this hydrogen fuel station there can be provided green hydrogen trains, and also some other energy can be supplied to the grid. So it is the picture of hydrogen trains in Germany that are under real operation in every region in Germany. For example, other very nice realization of hydrogen system is in New Schönefeld Airport in Berlin. That there is also the picture of hydrogen storage. The principle is the same. Use wind system or photovoltaic system to produce the hydrogen, and then the hydrogen can be used for buses and for passengers cars as a hydrogen hub. There also exist some hydrogens for family houses. There are a lot of producers of such systems, and similarly, like we have now the system for gas, similarly will exist for hydrogen. Very popular for storage of energy is power to gas system. That we have two words. First word is a classical power grid of electricity, where we have wind, sun, and other sources of energy. And second word is a natural gas grid, where we have storage of gas and storage of methanol. And there is the power station, and power station can generate the power, but we have also the storage of energy. And if we take the electricity from wind and sun and combine it with CO2, and then we produce firstly hydrogen, and then we combine it with CO2, it is metallization. So we can produce methane as a methanol as a gas, that power to gas through methanation have a very high and very good storage parameters. On this slide, for example, 1 cubic meter of methanol is similar like so many batteries, in BMW i3 cars. So it is very high efficiency, and these two words can cooperate in area. We have more energy on the side of wind and sun. We can store the energy and transfer this energy into hydrogen, and through the methanation to natural gas, and vice versa. If there is the lack of energy, the gas can be used to be transferred to energy. So it was only a short overview about hydrogen technologies that are well discussed in the European Commission and within Green Deal as a future of energy strategy of Europe and maybe of whole world. Thank you for your attention.